Good afternoon, everybody. Welcome to Tuesday afternoon. I know it's Tuesday because I put out my garbage this morning. I do that on Tuesday afternoon of Chem 170 with your host, me, Dr. White. Don't forget on Thursday, right after our lecture and lab, I will be sending out the password for test number 2. I've already gone over what's on test number 2 in terms of what's being covered, alcohols, ethers, epoxides, thiols, ketones, aldehydes. And that's an email, and it's also posted on D2L. Now, yesterday I did my world famous review for the next test. If you missed it, you can go back and look at the video. That's the nice thing about putting everything on YouTube in a video. And today, what I'd like to go through now is the problem set for ketones and aldehydes. So let's do it. All right, thumbs up, people. Everybody see aldehydes and ketones problem set with my monogram, the KW. Thank you, Jimmy. All right, let's look at number 1. Give the IUPAC name for the following. And if we look at number 1, what's different? Ooh, oxygen. Remember, look for what's different, what's not carbon, what's not hydrogen, what's not a double bond. Should get you. Ooh, it's not working today. It was working earlier. Hold on. Now it's not working. That's not working either. Hold on. Like that. And we have an oxygen double bond to carbon with a hydrogen and carbons. That's an aldehyde. How do you name it? Find the longest chain with the carbonyl carbon. Remember, the carbonyl carbon is the carbon double bond to oxygen. And in this case, it's butane, 4 carbons. For an aldehyde, drop the E, add Al, butanal. Excuse me. The carbonyl carbon is always number 1. So we're done. Now, if we look at B, we have, again, a oxygen, double bond to carbon, but here we got carbons here and here, and that's a ketone. And how do you name ketones? Find the longest chain that has the carbon double bond to oxygen in it, the carbonyl carbon, name it as a alkane, butane, drop the E, and for ketones, we use ONE. So that would be 4 carbons, butane, butanone. Unlike an aldehyde, you have to number which carbon has the double bond to oxygen. In this case, you always start from the end of the chain that has the lowest number. In this case, it's 2, so that's 2-butanone. Now, if you have C, it's in a ring. And when it's in a ring, you count how many bends in a line there are, and then 6. That's hexane. Ring, remember the cyclohexane. It's got an oxygen double bond to carbon. And that's a ketone because you got carbons here and here. And now we drop the E and add ONE. Now for carbon, carbonyl or ketone in a ring, the carbon double bond to oxygen to carbonyl is always number 1, always. There's no exceptions that I know of. Therefore, if that's 1, you number in the direction, give the other substituents lowest numbers, methyl on 3, isopropyl 4. Now, I'm not holding you to the alphabet rule, but I hold myself, and that's 3-methyl-4-isopropyl cyclohexanone. Now, if you had put 4-isopropyl 3-methyl cyclohexanone, I'd give you full credit. And if we look at Z, it's an aldehyde, carbonyl, carbon double bond to oxygen with a hydrogen and carbons. Longest chain is 7, heptane, aldehyde, drop the E, add Al. Carbonyl carbon is number 1, but you don't show it. I'll take all points if you do, so don't, for an aldehyde. And then on there, we have two methyls. Remember, di is 2, tri is 3. And when you have dimethyl, you need two numbers. One methyl group is on carbon 3, the other carbon 5. And if we look at F, we have, ooh, big molecule. And oxygen over here. Look for what's different. Double bond to carbon, carbon's here, ketone. How many carbons? Longest chain with the carbonyl carbon double bond to oxygen? 9. And that's nonane. Drop the E, add ONE, known and known. And then, guess what? What carbon is the carbonyl carbon? And if we start from this end, it's 3. The other would be a lot more than 3. So it's 3 known and known. If that's 3, there's 4, 5, that's 6, and that's an isopropyl. All right, there are two types of nomenclature skills, meaning questions I can ask on a test, and the other is draw the condensed structure for the following molecule. How do you do that? You start from the right and move left, right, left. Al ending, aldehyde. How many carbons? That were E6. And I write mine on the right. You can do it on the left too. And there you have hexanal. Now, AB is 3-octanone. Start from the right, move left. ONE ending, ketone. That were E octane, 8 carbons. Which carbon is double bond to oxygen, like you see in a ketone? The third one, and there it is. You can start counting from this side too. I don't. Now, I asked you to learn 2 common names, and there are different ways you could write it. Acetone is the simplest ketone, 3 carbons, the center carbon has the double bond to oxygen. And formaldehyde is the simplest aldehyde, where R is an H. And these are 2 ways you can write it. And here I have some more complex. Let's do F. What do we have? Al ending, right to left. That were E, decane, 10 carbons. Al ending tells you aldehyde at the end. I did. And then that's carbon 1, carbon 3, and I made a mistake. I have isopropyl. Oh my God. Mistake. There goes my perfect score. That should be an N-propyl and CH, CH2, CH2, CH3, and on carbon 2, a methyl. All right, let's look at reactions of how to make a ketone or aldehyde. If U and A oxidize, and that's what this O in a bracket means, oxidation reagent, a primary alcohol, you'll make an aldehyde. The carbon with the hydroxyl group is now the carbon double bond to oxygen. And that double bond counts as 2 bonds. Now, if you take a secondary alcohol like in B, you lose the hydrogen from the ring, hydrogen from the hydroxyl group, OH, alcohol, and form a carbon-oxygen double bond, and that's a ketone. And if I have a more complex, do you break carbon-carbon single bonds? No. So I start out with this chain with the isopropyl. I end up, the only place you change is the carbon with the hydroxyl group is now carbon double bond to oxygen. Same thing in D. All right, let's look at E. E is, what's different? Benzene ring. Then this is called an acid chloride. By the way, you can right or left justify the hydrogen. Seems like my software, I forgot to override it. Left justified 3 hydrogens. You can also have CH3 there. But what's different? Carbonyl, carbon double bond to oxygen with a chlorine on it. Acid chloride, aluminum trichloride, Friedel-Crafts acylation, and you make an aromatic ketone. And here's the structure, what's R, methyl, and that's what you get. And if we have a more complex R, like a benzene ring, you make this molecule. All right. Now let's go next couple of reactions. I will never give a synthesis, but I'll ask you, draw the product or products for the following. And that is, this is a what? Aldehyde. It could have been a ketone. Carbonyl, hydrogen, methyl. Carbon, carbon, OH, acid catalyst, H plus, alcohol. Keep your eye on the carbonyl carbon. What's attached to it, R prime or H. Our double prime will still be there. This will have an OH group, then an oxygen, and the R group from the alcohol. And so here's the carbon with the dot, becomes this carbon, H is still there, methyl. This becomes OH, O, and the R comes from the alcohol. Now, if we look at B, what do we have? Ooh, a lot of good stuff. Here we have carbon double bond to oxygen, carbons here and here. That's a cyclic ketone. It could have been an aldehyde. And ooh, the number 2, that's unusual. And here, carbon, carbon, OH, 2 alcohols, acid catalyst. Keep your eye on the carbonyl carbon, R prime or H, and R double prime, still there. It opens up to 2 oxygens, and each oxygen has the R group on there. And so what's our R and R prime? The ring. Remember, do you break carbon-carbon single bonds? No. What's our R group? The isopropyl. So you have that carbon, 2 oxygens, and each one has an isopropyl. And the next one is the same one. Now, if we look at D, we have an acetal or ketal. This is an acetal. This is rare. Carbon single bonded to 2 oxygen atoms. In this case, each one has R on them. And here on the carbon with 2 oxygens, you have H and R prime. That H also could have been, or R double prime. The H could have been R prime. Add acid and water, what's attached to the carbon with the dot with 2 oxygens with carbon or hydrogen still there, and you form a carbon oxygen double bond to form the ketone or aldehyde you would have used to make that compound. And then you get the alcohol. You want to put the 2 there, you can, you don't have to. And E and F are the same. And I'll come back for another, I'll do it now. Just noticed I didn't have this type of problem there. And let's look at this reaction. What's different? Carbon with 2 oxygens. And I have carbons here and here, which I call R prime, R double prime. Now the R prime could have been hydrogen, it's not. On that carbon, we have a hydroxyl group, oxygen, and carbons. And it's a hemiacetal, or in this case, hemiketal, and acid and water. Keep your eye on that carbon, what's attached to it, R prime, R double prime is still there, and this is double bond to oxygen. In other words, it's the aldehyde or ketone you would have used to make that compound. And then this group here becomes this alcohol. And I'm going to let you figure out what's the product because I've done the hard part for you. Your turn. Thank you, Jimmy. When you're done, give me a thumbs up. And while you're doing that, thank you, Jordan. Earlier today, I mailed in my mail-in ballot, so I voted today. I have until I have, the way it's set up, it has to be postmarked by today, and I dropped it off in my local post office. So I know I'll get stamped today. All right, I think everybody's done. Let's take a look at this. Here's the general reaction. I have things, and this is my R group. So keep your eye on this carbon, which is this carbon becomes this. So I'll do that. Double bond to oxygen. What's our methyl? What's our double prime ethyl? So you get this ketone. And then what's the alcohol? Well, our is methyl OH. And that's how you do it. And I didn't have a practice problem. Sorry. Once in a while, I'll miss something like that. All right, let's look at 5A. What's different? Oxygen, double bond to carbon, carbon's here and here. Ketone, it could have been aldehyde, it's not. Hydrogen, a catalyst, nickel. I didn't put down, but by now you know catalyst can be nickel, platinum, or palladium. You break the pi bond, and each atom of the double bond carbon oxygen gets a hydrogen. And you could write it either of these two ways, and you make a alcohol. And if we look at B, same thing, break the pi bond, and each carbon, each atom of double bond carbon oxygen gets a hydrogen. Now, as I mentioned, hydrogenation will also attack carbon-carbon double bonds. When you don't want that to happen, use lithium aluminum hydride, LiAlH4. First step, second step, H+, which is acid and water. And if you have an aldehyde or ketone, D is a ketone, carbon double bond to oxygen, carbonyl. By the way, you should know that carbon double bond to oxygen is a carbonyl group, and you should know how to describe with words and a diagram what is a carbonyl group. And here we have a ketone, lithium aluminum hydride, second step acid water, does the same thing as hydrogen and catalyst, but this will not react with double bonds, carbon-carbon double bonds. But a carbon oxygen, yep, it turns it into an alcohol. You break the pi bond, each atom with double bond gets a hydrogen. Now, let's look at A. A is, very interesting. What do we have that's different here? Carbon double bond to oxygen, carbon's here and here, ketone, could have been an aldehyde. Ooh, what's here? Carbon, magnesium iodide. That's a Grignard reagent. And X I don't have here, but can be chlorine, bromine, or iodine. This case is iodine. Second step, acid and water. What's attached carbon-wise to the carbonyl carbon still is. And now you do that special thing. You form a carbon-carbon single bond from the Grignard to what was the carbonyl carbon, which has opened this up to an alcohol. And here's the two different ways you can write that product. And if we look at C, same thing, carbon, double bond to oxygen, carbon's here and here, a ketone, we have this Grignard. Now, the carbon with the MgI, or X, is the carbon that's going to be bonded to the carbonyl carbon to make this alcohol. The carbon in R triple prime with the MgX will bond to the carbonyl carbon, and therefore I have a ring, it's still there. Do you break carbon-carbon single bonds? No. And This carbon bonds to that one, isopropyl, and this is our alcohol. And finally, I have the aldol condensation, which we'll talk about of complex wave aldol condensation in today's lab. Now, remember, the alpha carbon bonds to carbonyl of an aldehyde, and it's ketone too, but for my class, this reaction, I'm limiting it to aldehydes. You have acidic protons, base and water, sodium hydroxide is base. You form the enolate anion, you remove one hydrogen that attacks, bonds to the other carbonyl of the other aldehyde, and it opens it up to an alcohol. So if we look at E, carbonyl carbon attacks that, forms this long bond, opens it up. What's attached to that is still attached. And the same thing, I think on this one, I have an extra CH2 on the bottom. In fact, I can see it. Oh no. 2 mistakes. I'm going home. Wait, I am home. All right. And that's the problem set. But I noticed there's one other thing I didn't do. So let's practice it. And that's this reaction. You have a alkyl halide reacted with magnesium. You form the Grignard reagent, which Victor Grignard discovered. Remember, this is wrong. This is wrong. No, you've never have magnesium bond to the halogen still bond to carbon. Nothing like that exists, period. So your turn. Why don't you try this? Here's a practice problem. When you're done, give me a thumbs uppy. Thumbs uppy. Isn't it interesting? In Zoom, they don't have this. And remember the Outlaw condensation I just showed you. I will never put a synthesis problem on the test or final for those. And when you're done, give me a thumbs up, please. Thank you, Jimmy. Thank you, Jordan. Thank you, Janet. Let's get to work. What do we have here that's different? Ooh, halogen on a carbon, and that's an alkyl halide. X can be chlorine, bromine, or iodine. Add it to magnesium, and you get the Grignard reagent. And what's our isopropyl? What carbon has the halogen? This one, that will be the one bond to magnesium, and the halogen is chlorine. And there are 4 bonds to carbon. Oop, that's correct as is. And I'm done. Oh, let's do one more. And what would I react with magnesium to make that compound? Your turn. Thank you, Jimmy. Sorry about that. This summer, my days have been long and they start early and end late. Wow. Keeping me busy. All right, anybody need more time? All right, let's do this. We look here. What's different? What's not carbon? What's not hydrogen? Ooh, magnesium iodide. And that's this here, I'll call R. It's carbons and hydrogens. And that's a Grignard. Remember, X here can be chlorine, bromine, or iodine. And what do you react magnesium with to make that? And the answer is alkyl halide. Now, in this case, what's X? Well, we can see it, iodine. And the carbon with the magnesium iodine, or in this case, halide, is the carbon that the halogen will be on. Do you break carbon-carbon single bonds? No. So I have a ring. I'm going to start with a ring. I have 2 methyl groups. I start with 2 methyl groups. The carbon with the halogen, or the Grignard, is the carbon that will have the halogen. In this case, iodine. And I'm done. If you take that, react with magnesium, you will get this compound. And that's how you do it. All right, any questions, anybody? And if you do, don't forget, you're also welcome to come to my office hour tomorrow on Wednesday. Well, in that case, it's time for me to move forward. Everybody see on your screen an acid is? Thank you, everybody. All right, now let's, where I left off yesterday. Any acid under a Bronsted-Lowry, any base, you get a proton transfer and you get a salt. This is an acid-base reaction. In reality, I should have had here an equilibrium. Now, for organic chemists, a carboxylic acid is an acid. And this hydrogen, which I could write like this, is acidic. And water you get the carboxylate anion, plus this case, you create the hydronium ion. And that means this hydrogen on a carboxylic acid is an acid. And what does that mean? Well, real quick, what makes a carboxylic acid acidic? That proton come off like that, and ethanol, it doesn't. And the answer is resonance stability. Switches off, click for this slide, but now in an acid, when I form the carboxylate anion, I can move this the electrons and form another resonance form. Again, switches off. And this is different from just rotating it. This is actually another form. Now, for an alcohol, you have no other resonance form. When you can draw resonance forms, you make it more stable. When you make something more stable, it's likely to go there, meaning it's a stronger acid. And that's why. All right, if you were reading the book, I'm skipping section 10.5. Now, since carboxylate anions are acids, when you react it with a base, you'll get a salt. Now, here I have the sodium hydroxide. Let me show you a better way. You take any carboxylic acid, and react it with a base. Now write the base like this, and usually you do this in water, you don't have to. What's M? And here's where I expanded it after I wrote that slide. Oops, made a mistake here. And M can be a sodium cation, potassium K plus, and lithium. And what you get, acid-base reaction, and you'll get this carboxylate anion plus water. And you know from my test, I only ask if the organic product or products, you don't have to put down the water. And that's how you make carboxylate salts, which I'll show you is quite important compounds. So let's try this out. And if we look at this, the question is, what's the organic product or products for the following? Remember, these are ways of making things we chemists use to help make things that are in your daily life. And here, what do we have that's different? Ooh, oxygen here and here, double bond to oxygen to carbonyl, OH. This is carbons. I have a carboxylic acid. Ooh, KOH, water. And what do you get? The acidic proton is taken off. And you get this carboxylate anion. In this case, what's R? 2 carbons. What's M? Potassium. Another way of looking at it, you start with 3 carbons. You better end up with 3 carbons, carbonyl. And the oxygen on the carbonyl coming this way has the negative charge. And what's our cation? And then there are 4 bonds to carbon. And there you go. Now, listen carefully, and I'll mention this again next week after test number 1, or number 2, I'm sorry. And notice here I showed charges. What if you wrote it this way? Which I wouldn't, but what if you did? Guess what? I'd mark it correct. In the past, I used to mark it wrong. It took off a point. You didn't show charges until a student of mine, 170, challenged me on that. I said, well, if you can convince me what you're doing is correct, I'll accept it and give you full credit. So he said, this compound, how do you write it? And I said, like this. He said, how come you don't show the charges? Well, you don't have to. And he said, then why do I have to show charges? I said, you win. I will when I write carboxylate anions, but if you don't, that's okay. Oh, quick thing. Everybody know what NaCl is? Sodium chloride, table salt. If you ever go out to dinner, lunch, or breakfast with organic chemists or any chemist, but mainly organic chemists, one of us will invariably say at the restaurant, can you please pass the NaCl? NaCl, never mind. All right, so carboxylic acid, base, and water, you get the carboxylate anion. And there's one for you to try. And I better help you out. There's a general reaction to help you out. There you go. And when you're done, don't forget, thumbs up. Or better yet, well, let me give you some time to finish up. Thank you, Jordan. Thank you, Jimmy. And we'll wait because we'll be polite. And we don't have to wait anymore. Thank you, Janet. All right, let's take a look at this. What's different? Ooh, carbonyl, carbon double bonded oxygen with a hydroxy group in carbons, a carboxylic acid. What are we reacting with? Oh, lithium hydroxide. I can show like this with water. And what can M be? Sodium cation, lithium cation, or potassium cation. And what do you get? This is acid, this is a base, proton transfer, you get a salt. Let's make that clearer. And that's the salt you get. You don't have to show charges, but I do. And what's our R group? Isopropyl. Think of it, do you break carbon-carbon single bonds? No, you have 3 across plus a methyl or the isopropyl on this carbon. And this carbon is this one. So it's still double bond to oxygen, O minus, and what's M? Lithium. And now I'll put my 4 bonds to carbon. And I'm done. Now, we'll learn later on that when R is long and you have a lithium carboxylate anion, they make very good lubricants. And you can buy some of them at Home Depot. You know something? Instead of rushing through a problem now, I'm going to give you a whole extra about 45 seconds and a break. So let's take a 5-minute break. I'll see you at 2:50. And we'll continue on with carboxylate anions. I can get up and stretch. I had the wrong time. Should have been 2:55. I was running late because I checked my mail. Something I was expecting came. I'm a happy camper. All right, let's continue. We're talking about carboxylate anions reacting a carboxylic acid with a base in water, and you get the carboxylate anion. And let's try a synthesis problem. Remember, this stuff is going to be on test 3, not test 2. And the question is, your turn. What do you react with sodium hydroxide and water to make that compound? Remember, thumbs up when you're done. Thank you, Jimmy. Thank you, Janet. All right. Thank you, Jordan. So the question is, how do you find out? Excuse me. I think I got a frog in there. Ribbit, ribbit. Anyways, how do you find out? What do you react with sodium hydroxide and water to make this compound? What's different? Well, I got a benzene ring, but in this case, I'll just call this R, because that's not going to react at all with sodium hydroxide. But I have a carbon double bond to oxygen. That same carbon has a negative charge and a cation. And what can that cation be? Sodium plus, which it is. It could be potassium, or it could be lithium cation. And what do you react? Well, a base and water. You can use other solvents. And M in our case is Na. So actually, I should do it this way to be correct. There, because over here, well, I could have left it that way. But anyways, what do you start with? A carboxylic acid. And therefore, what's our benzene ring? Don't forget to put the lines inside. And then carbonyl and a hydroxyl group on it. And there's a carboxylic acid. Let me clean that up a little. And that's what you start with. And that's called benzoic acid. And I don't know if I think I mentioned it. If not, I should have. And that's benzoic acid. And why am I talking about this reaction? Well, as I've said many times this semester, you should ask, why are you learning this? And the obvious answer is you want to get a good grade in this class. Someone said you had to take it. But really, why are you learning it? Why do they want you? Well, if we look at what you just made here, that's called, and I'll teach you the nomenclature later in the chapter, sodium benzoate. And if you happen to have a can or bottle of pop, remember that stuff that's a liquid that's carbonated, non-alcoholic in a bottle or a can here in the Chicagoland area, you'll see near the end of the ingredients this. And this is a preservative put into pop so it doesn't go bad, whatever go bad means. And how does it work? I have no idea. I'm an organic chemist. I don't know how that preserves things, but it does. Now let's talk about a very special base, and that is sodium bicarbonate. And sodium bicarbonate you can find in your kitchen. And that's baking powder. Now, baking powder, you know, the stuff in the little red can called Calmet baking powder, or you can find a yellow can, has the strange name made in Indiana called Gabler Girl, and they're essentially sodium bicarbonate, this. And if you take a carboxylic acid, you get the carboxylate anion, water, and carbon dioxide given off as a gas. Well, let's take a look at why this happens. Now, switches off on the mechanism, but the general reaction you could know. Mechanism is what's happening step by step. All right, that's the overall reaction. But now let's do a reaction stepwise. First step, this is the acidic proton. Here's our base. Well, let me draw the structure of sodium bicarbonate. And that's this right here. And now if I give a proton to this, this will become OH. And I'm going to put it in brackets because you can't isolate it. As soon as you form it, this breaks down. Now, if we look at this, and this has a name, carbonic acid. And if I look at this hydroxy group and that hydrogen, let's see, 2 hydrogens and oxygen, 2 hydrogens and oxygen, that's water. And if you take this and this, what's left? 1 carbon and 2 oxygens. That's CO2. This immediately breaks down to water and CO2. And that's what happens. Now, let's take a look at the following reaction. Well, first of all, in case you're writing this down, I'll give you a chance to catch up. Not for this chapter, but for Thursday, the material on there. Did anybody happen to drive by a gas station and see they say this gasoline contains up to 10% ethanol, and ethanol is an alcohol? Did you happen to look at a bottle of wine or hard spirits like the good stuff vodka, and that contains ethanol or ethyl alcohol, which is an alcohol? And did you have like good vodka like Grey Goose or Canadian or Absolute? Did you happen to look at a bottle of rubbing alcohol and see it contains isopropyl alcohol, which guess what? It's an alcohol. And finally, did you happen to look at a bottle of nail polish remover? I forgot to polish my nails, but I don't, period, but it sounded good. Did you look at the bottle of nail polish remover and see it's got acetone, which is the common name for the simplest ketone, which is a ketone? You should do that because organic chemistry is all around you. I stole that from SpongeBob, and it wouldn't hurt for you to think about that. All right, let's get to work on this reaction, and I'm going to do something different. I'm going to make a mistake. Say Friday the 13th. Actually, that's a lucky day. If you were to see this, say 4 points, give all the products for the following. And we say, oh, what's the different? Oh, carbonyl with a hydroxy group and carbons, a carboxylic acid. Oh, what's this? Baking powder for sodium bicarbonate. And when we react that, this is a mild base, a weak base. And what do you get? You get the carboxylate anion of the carboxylic acid you started with. And since it asks for all the products, you also get CO2, and the arrow up tells you that's given off as a gas, and you get water. So if I look at this, this is my R group. I start with 3 carbons, I end with my R group, 3 carbons, carbonyl. This carbon is this carbon, becomes this carbon, becomes this. And then if you look here, it's got an O minus and A plus. I can put in my hydrogens real quick, because I know there are 4 bonds to carbon, but it asks for all of them, and it doesn't matter the order. CO2 given off as a gas, that's what that arrow up means, plus water. And that's how you do the reaction. And so you get 3 things, and it's your turn to figure out what are all the products of that reaction. Thank you, Jordan. Thank you, Jimmy. And we'll be patient and wait for everyone to finish. Thank you, Janet. All right, let's take a look at this reaction. And the question is, what's all the products? And there are 3 of them here. And what do we have here that's different? Carbonyl, carbon double bond oxygen, but it has a hydroxy group and carbons, and that's a carboxylic acid. And here's my R group. Ooh, what's this? Baking powder, sodium bicarbonate. And what do you get? Acid-base reaction, the carboxylate anion of the carboxylic acid, sodium, because that's what this is, and you'll get water, doesn't matter what order, and carbon dioxide, and that's given off as a gas, which is what that means. So that's how you do it. what's our T-butyl? Got my carboxylate anion. There's 4 bonds to carbon. I do that, and then I'll get water plus, and the third thing, carbon dioxide given off as a gas. And that's how you, oh, let's do another one. This was fun. And you'll get 3 products here. Your turn. What would be the product or products for the following reaction? Thank you, Jimmy. Thank you, Jordan. And we'll wait for everybody to finish because we're patient. Thank you, Janet. All right, let's do it. What's different here? Ooh, carbonyl. Look for what's different, what's not hydrogen, what's not carbon. Another oxygen, here's the first oxygen with a hydrogen bond to the same carbonyl carbon. And then you've got carbons here, R. In this case, R is methyl. Ooh, sodium bicarbonate, baking powder. And you get 3 products. The carboxylate anion of the carboxylic acid you started with, plus water, plus carbon dioxide given off as a gas. So what's our methyl? So I'm going to get this compound. And I'll get water plus CO2 given off as a gas. Now, does anybody see the significance of that reaction? And the answer is, what's this compound right here? And that's called the common name, acetic acid. And where do you find this? In vinegar. So essentially, you could take vinegar and baking powder, and this is what you get. Now, it's time to tell you something very personal. It's time for me to talk about the very first chemical reaction I did with my hands. As soon as you're born, maybe even before, and throughout your body, you're doing chemical reactions, but it's the first one I did with my hands. Now, when I was about 5.5 or 6, the big thing in the United States, in the world, was the space race. And who could get to space first? Who could get to the moon first? And it was the United States versus the evil Soviet Empire, Russia and its satellite countries that were part. That's when Ukraine was part of the Soviet Union, which I'm glad it's no longer, and I hope they win that war. That's my personal opinion. But, and also other countries like Belarus, et cetera, et cetera. And Lithuania, I think, was also part of the Soviet Union. I don't think by choice. Well, anyways, everything was focused on the space race, rockets, outer space. That meant the little kids wanted anything as toys to play with that had rocket ships or was with outer space. Some of the TV programs were all based on that. If you have a chance, check out Rocky Jones Space Ranger on YouTube. Oh, I love that. Even though in their rocket ship, their chairs that they blasted off in the control room were really office swivel chairs. But when you're 5 years old, they still look cool. Now, what did I do? Well, I should really say, what did my father teach me? Now, I have a warning. Dr. White is going to do some artwork. My mother was a very talented amateur artist, and not one iota rubbed off on me. I am not an artist. I'll never go to art school. So be careful. I don't want you laughing too hard when I do a drawing that you break a rib or anything like that. All right. Now, when I was that age in the space race, you could buy, I think it was only a penny, but a penny was a lot of money back then. This, some candy, they were these little dots that were the most awful candy in the world. I'll explain why, how you know it was awful. That came in a tube that had a cap that had 3 fins. And it looked like it was a little rocket ship. It's about this big. And you had this really bad candy. They're about a penny, I think a penny a piece. And how do you know it's candy? Because you give it to a 5, 6-year-old, which I would do and my friends did. You took this cap right here off, took the candy in there, you didn't eat it, you dumped it in a garbage can. It was really bad. But afterward, you had a little rocket ship to play with. And this was now a hollow tube. Well, my father showed me, and he loved chemistry. I wonder why I became a chemist. Don't know. He was a pharmacist, but I think he always wanted to be a chemist. If you take this tube that's empty and invert it, it looks like a little test tube. If you put some vinegar in here, and then up here, you put in some powdered, which it is a powder, sodium bicarbonate, baking powder, slam the cap back on and hold it by its fin right there. What happens is actually this is all mixed together. Don't laugh too hard. And you have the cap on there. Inside here, the tube, you have this reaction. The vinegar, sodium or acetic acid, the baking powder, you react it and you get this carboxylated salt. All right. Water. But the most important thing, you see bubbles and you form this gas, CO2. And the gas builds up pressure here till the top pops off. And it looks like you just blasted off your rocket ship. And it was cool. If your timing was good, mine was, my best friend Dickie Gale's was, if you mix it, hold it, and the thing would pop off, you could get it to go about 4, maybe even 5 feet, usually about 3, 4 feet. And when you're 6 years old, 5.5, 6, it's exciting. It's wonderful. I can still remember that. I can actually picture Dickie Gale and me playing by our apartment with some vinegar and acetic acid and those little rocket ships. Oh, did we have fun? Now, bad thing happened to my friend Dickie Gale. What? Well, he used up all his mother's baking powder and didn't tell her. And she went to use it for cooking, opened a can, it's empty. And she was upset. Oh, did he catch it? So never use up all your mother's baking powder without telling her to get more, or you buy more. Now, that's one thing. Now, the same type of reaction, I'm going to share with you something very secret. It's my father's secret recipe for spaghetti sauce. And he uses chemistry to make it really good. Now, when you make spaghetti sauce, you take tomato paste, tomatoes, or tomato paste, tomato sauce. We used to have a hand grinder when we do our own tomatoes. You buy cans of whole tomatoes to make tomato sauce to make it taste really good. And then in a big pot, you do that. And we had a freezer, and my father, which to this day, I do the same thing. You make a lot of something and then freeze it in smaller containers. So when you need it, take it out of the freezer and thaw it out. Back then, we didn't have microwaves. I just showed my age. But anyways, he'd make about 3 gallons at a shot, maybe 4. We had big pots to do that. And on Sundays, because he had a pharmacy and he worked Monday through Saturday, once in a while, he'd tell everybody, the men are cooking in the kitchen, women out, we're cooking. And I'd have some quality time, a real quality, good time with my father. At a young age, when most guys didn't cook, I learned how to cook. And it was quite interesting because by the time I got to college, most of my friends couldn't cook, and I could. And when we had dinner on the weekends, because our cook didn't work the weekends, I'd wind up cooking it. But anyways, you have tomatoes, tomato paste, tomato sauce, put in some seasonings. I won't go into that except one secret thing I'll tell you about, and you heat it up and cook it. Now, when you use the secret, you put in less salt, and I'll explain why. In tomatoes, there's citric acid, and citric acid, which I showed you similar to limes, is it citric acid? Yeah, citric acid. This is a carboxylic acid. I'll just write this. And CO3. And what this does is neutralize, react with some of the acid from the tomatoes to make this, which is a carboxylate anion. And this tastes salty to your tongue, which is why you cut down the actual salt you put in. And you get water plus CO2 given off as a gas. When you do this, you see all these bubbles and foam on the top. Now, in a big pot, you only use about a teaspoon or teaspoon and a half. I'm talking a couple gallons. Well, what does it do? It neutralizes the acid, so the pH, remember, 7. Below that, it's acidic, goes from 0 to 14. Above 7 is basic. So if you start out with something acidic and you add this base, the pH increases and you make it somewhat mildly base or neutral. Well, that has an immediate effect on the taste, makes it taste milder. Now, the other secret, have you ever made your own spaghetti sauce and it doesn't taste like that real primo stuff, the best stuff you get at a really good restaurant? Well, the secret, but I don't know how we found this out, was you add a pinch of cinnamon. Yep, cinnamon. And cinnamon goes good with tomatoes. Now, you got to be careful. We're talking about maybe a 1/4 teaspoon of cinnamon in a couple gallons. I had a friend of mine, I told him about it. He made a couple of quarts, put a whole tablespoon of cinnamon. You couldn't even taste the tomatoes. It was this cinnamon liquidy stuff. No. And that gives it its official, I mean, really makes it taste like the good stuff you get at the best high-end Italian restaurants. So Adding the base increases the pH, makes it taste smoother and milder, and it's good. Now, a number of years ago, I had a Chem 170 student who came to me after I taught that a couple of weeks later and said, my father and I would like to thank you. I said, all right, you're welcome. What are you thanking me for? And says, your father's recipe for spaghetti sauce, we tried it. It was wonderful. I said, you're welcome. And they said, I really need to thank you. I said, why? What's the reason? Says, both my father and I suffer from acid reflux. That's where you have a condition. The acid from your stomach comes up into your esophagus, I guess, and it can be very painful. One company I worked at, another manager had that so bad that he had to have an operation to help fix it. And she was telling me my father and I love spaghetti sauce and spaghetti and meatballs, but because of the acid in the tomatoes, after we eat it, boy, do we suffer. It's painful and it causes a lot of acid reflux. Well, we tried your method. It neutralized some of the acid and we didn't get sick. We could eat it all, have a good time, and we didn't get sick. And I thanked her for sharing that with me. But don't forget, if you use up all the baking powder, tell your mother so you can get she gets more. But if you put cinnamon in just a little bit in a big pot and stir it to taste, you'll see, wow, that makes a big difference. Just a little. And so does the baking powder. And that's 2 secrets of Dr. White's father's secret ingredients. All right, a couple of things just to remind you. I talked about this carboxylate anion called sodium benzoate, and it can be potassium too, but it's mostly sodium. Now, there's a preservative in bread, commercial bread. And if you go to a supermarket and buy some bread or go to a bakery, take it home and look at it 3 days, 2 days later, are you going to see any mold or green gunk growing on there? No. Why? Because there's a preservative in there, and commercial baked goods have that, bakery goods, to protect it from mold growth and that green stuff growing on there. I like that. But anyways, what is that stuff? It is dun, 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 calcium propanoate. Now, calcium salt is a +2. And all molecules in nature have a net 0 charge. So if this is a -1 and calcium is a +2, you need 2 of these. And I won't ever ask this on a test, but this is the molecule that keeps your bread and bakery goods from molding on you. And I'll talk about another special carboxylate anion or salt that we use as soap later in the semester. Now, one other thing I do want to mention real quick, how many of you have heard that you should be having a lot of calcium in your diet, so you have strong bones, and you won't get osteoporosis or other problems with your bones, very bones that can break easy, have strong bones. Well, anyways, are you eating calcium metal? No, it'd be like the string gold. It'd be hard. You're not going to chew on that. What are you taking? Well, let's take a look. Oh, I was wrong. It wasn't well, I did say citric acid. I wasn't. Everybody see the structure on your screen right now? This is calcium citrate. And this is a citric acid, and you have 3 of these, and the calcium is a +2, so you need this 2 of these, 3 of these. This is the way you get your calcium. As the salt part, calcium +2, of a carboxylate anion. And this is how you get it. If you go and get the better name brand calcium supplements, that's what you're buying, which I take, because at my age, I don't drink enough milk, or I don't drink any really. I'm not a milk drinker now. I used to be when I was younger. And so I want to get enough calcium in my body to keep my bones strong. And I take a supplement, calcium citrate. Now, if you look at things like milk or other products, they say fortified with calcium. Now, are they talking about calcium metal? No, they're talking about the calcium citrate carboxylate anion. Now, how do you make a carboxylic acid? One way is oxidizing a primary alcohol. This is a primary alcohol. But you'll say, Dr. White, for test 2, and you should know this. Uh-oh. Let's do this. Let's do this. Let's end this. I'll be right back, opening up stuff. Oh, by the way, after the semester, I decided to wait, and also I'm waiting to buy them, get them in stock. I'll be adding more memory to this machine, so it stops doing that, I hope. But let's open these up again. All right, sorry about the delay. All right, was talking about oxidizing a primary alcohol. For test 2, you make the aldehyde. Now, it's hard to stop here because this you'll learn later can go all the way there, but I'm not talking in this class about reaction conditions. I know the ones where you can either start here or go all the way to that. For test 3, this is the reaction I'll be teaching you. For test 2, you should know this one. All right, so if you have a primary alcohol, oxidize it, you'll get a carboxylic acid. And what do we have here? What's different? Hydroxy group on carbon. And this, because we're oxidizing it, it's a primary alcohol. And for test 3, you'll get a carboxylic acid. The carbon with the hydroxyl group becomes the carbonyl carbon. And I can look at this and say, this is R, 3 carbons. Then I get this. And there you get that carboxylic acid. And that's how you do it. And it's your turn. What's the product or products for the following reaction? I just realized it always happens. I apologize. Yep, somebody should turn on your, I just realized when I didn't see my thing. Let's go to the screen. And I'll review this and then we'll take this up after the break. If you take this molecule and oxidize it, what's the product you get? If you look right here, what's different? Carbon with the hydroxyl group, but when you're oxidizing it, you write it this way as a primary alcohol. When you oxidize it, this carbon becomes this carbon of a carboxylic acid. So here's my R group. I have my R group. This carbon becomes this carbon, which is double bond to oxygen and a hydroxyl group. And that's how you get a carboxylic acid. And if I look at the clock, I'm going to let you go for about 30 seconds earlier than normal. And let me see if I can add correctly. Well, that looks like a price. Come back at 3:50. Let's take a 5-minute break. Well, it's right on time. I'll see you in 5. All right, let's get back to work. I was talking about how do you make carboxylic acids. And one way is oxidizing a primary alcohol. And here, if you take a primary alcohol, oxidize it, that's what O in a bracket. Here's the general reaction, you'll get a carboxylic acid. The carbon with the hydroxyl group becomes the carbon double bond to oxygen with also the OH. So here's one for you to try. Have fun. And when you're done, don't forget, thumbs up. Thank you, Jimmy. All right, let's move forward. We look at this molecule, what's different, what's not carbon, what's not hydrogen. Ooh, oxygen with a hydrogen and a carbon, and we're oxidizing it. So this is a primary alcohol. And for carboxylic acids, when you oxidize a primary alcohol, you get a carboxylic acid. And what's our this? And this carbon is this carbon becomes this carbon. So we have our R group, 3 carbons, this carbon, which will have double bond to oxygen and OH. And I can put in my 4 bonds to carbon, and that's what you got. Oh, let's do one more. And here you go. What would be the organic product or products for that reaction? 3 points each. Your turn. Enjoy. And for those who came in late, this is the reaction we're practicing. And when you're done, give me a thumbs up. Thank you, Jimmy. Thank you, Boris. All right, let's go ahead and do this. What's different here? Ooh, what's not carbon? What's not hydrogen? Oxygen with a hydrogen and a carbon. But when we see oxidation, O in brackets, that means we should put this down as a primary alcohol. When it's oxidized, the carbon with the hydroxyl group becomes a carboxylic acid. In this case, what's our methyl? So this is the product we get. Anybody see the significance of that reaction? If you want, send me a chat if you do, or if you give up, give me a thumbs up if you don't and you want me to go ahead. Think about the significance. Well, I got one person. All right, I'll go ahead. What's this molecule right here? It's an alcohol. We call that ethanol. And what's this molecule? Common name is acetic acid. And this is a reaction wine lovers hate. Have you ever tasted bad wine or wine that's gone bad? And what does it taste like? Vinegar. What happened? They didn't seal it well, cork it properly, and some air got in. Now, air is a very, very slow oxidizer, O in a bracket. And any of the air over, say, you save the bottle for 10 years, good stuff, you do that even longer. Some of the alcohol is converted to acetic acid. And what's also in wine? Water. And what is acetic acid and water? Vinegar. And that's why wine that's gone bad tastes like vinegar. Right after undergrad, one of my fraternity brothers started doing real well programming. It was new for banks and everything. He was making a lot of money. And he had this condo with a huge wine rack. And what he would do is when it was full, he invited a bunch of us over and said, I got to get rid of some of this wine. Let's have a wine tasting party. And we did. Some of the bottles back then were like $100. Once in a while, rare, but it happened. He'd open a bottle of wine. We'd taste it and say, oh, it tastes like vinegar. And he said, oh, no, this went bad. That's because of that reaction. All right, now, I think this would be a good time. I'll stop at this reaction and we'll pick it up tomorrow because it's lab time. It's time for us to have our lab. And what's today's lab? Well, first of all, I got to open it up. Let me close this first. And first of all, since I messed up earlier, everybody see Aldehydes and Ketones Lab on the screen? Thank you, Jimmy. All right, today's lab deals with aldehydes and ketones. And let me remind you, this is an aldehyde. Carbon double bond to oxygen with a hydrogen in R group. And this is a ketone. Now, the first part is the kind of reaction you've done or investigation you've done in the other labs. Let's look at the solubility of aldehydes and ketones in water. In this lab, you'll take a small test tube, put a little water in there, put a few drops of whatever you're testing, aldehyde and ketone, and find out, is it soluble or not? And here's the data for that. Now, notice for this table, I asked you to underneath, draw the structure for benzaldehyde, vanillin, and so on. And that's the first part. Now, the second part I had with odor, but let's just omit it. Now, the third part deals with oxidizing aldehydes and ketones. And let me first show you the reaction, and then we can see a video. As I'll teach you tomorrow, you can take an aldehyde oxidize it and get a carboxylic acid. Now, one of the oxidizing agents instead of doing this, I'm going to write a specific one. And this is potassium permanganate, and that should be a smaller N, KMNO4. In solution, acidic solution, I think Dr. Daly makes up, this is purple. If this gets oxidized, this gets reduced, and you make plus manganese dioxide. And this is I call it muddy brown. So if you take an aldehyde reacted with potassium permanganate solution, you'll see a muddy brown color. Now let's look at a ketone. That's a better way of writing KMNO4. This is still purple. And for this, ketones can't be oxidized. No reaction. So if you wanted to find out does the molecule have a ketone or aldehyde, you mix it with some potassium permanganate solution. Wait, if you see muddy brown color in the test tube, it's an aldehyde. If you see purple, no reaction, that tells you you had a ketone. And therefore, for this, hold on. I did the review yesterday. Hold on, Jimmy, let's find out. Maybe I'm mixed up. Let's find out. This is yesterday's lecture, posted. All right, you're here, I'm here. Let's get started. Good afternoon, everyone. All right, let's take a tautomerism. Just a product. Oh, was, and seriously, if you don't know if something's an aldehyde, an ether, an alcohol, I guess I didn't. Friends, the only I made a mistake. Hexane, drop the E, add O. Oh no. When I react this with base, I'll pull a hydrogen off there. All right. To form the enolate anion. Now the enolate anion is looking for. I made a mistake. Well, I wanted to separate them. All right, first of all, Jimmy, thank you for bringing that to my attention. What I'll do first thing tomorrow morning, first thing in lecture tomorrow, which is Thursday, I will do the review for test number 2. See, it's official. I'll put that on my mirror. But either way, one time, I will do it tomorrow. You have my word on that. I'm going to put this on my mirror in my bathroom That's where I put important notes to me so I can make sure when I get up in the morning, oh, that's what you got to do. And I'm sorry about that. Okay. All right. Let's go back and talk about the lab. Now, here's the lab. And let's look at this video.
We should file a claim.
Just did.
Aldehydes are oxidized by potassium manganate 7 to the corresponding acids. As the reaction proceeds, the purple color of manganate 7 ions fades away and a dark brown precipitate of manganese 4 oxide is formed. Aldehydes are also oxidized by potassium dichromate 6 in acidic solution. The orange color of the dichromate 6 ions changes to green, which is characteristic of chromium 3 ions. Aldehydes are oxidized by potassium manganate 7 to the corresponding acids. As the reaction proceeds, the purple color of manganate 7 ions fades away and a dark brown precipitate of manganese 4 oxide is formed. Aldehyde.
And you can look at that at your leisure again. But what you saw, and when we do it, we have more permanganate in there. It looks a muddy brown. Now, for this experiment, you're going to put about 1 to 2 milliliters in a test tube of the reagent, KMnO4, potassium permanganate, and then add about 5 or 6 drops of what you're testing. Now, the first one is benzaldehyde. You should know that's an aldehyde. Oh, I'm not going to give it away. Second one is cyclopentanone. First one, you get muddy brown. Second one, purple. Then, to make it exciting, we have an unknown. And the unknown is, you've got to figure out what functional group is it. Is it a ketone or is it an aldehyde? And I'm not going to give it away, but the color of the test does. All right, let's talk about the last one Dr. White said. This is such a fun reaction to do in the lab. And this is called a crossed Aldo condensation. And what it means by crossed is you have 2 different compounds. This is an aldehyde. And this is acetone, which is a ketone. And you add base, and we usually use ethanol as a solvent for this lab. We do. I didn't put it there. And what you get is this really complex molecule that has the common name dibenzyl acetone. And how does that happen? Well, I'll show you in a second. Now, what we do is we mix a certain amount of benzaldehyde and acetone in ethanol. You swirl it in an Erlenmeyer, then you add 2.5 milliliters of base, and you start swirling for about 5 minutes. All of a sudden, you see this yellow solid form in there. And then we collect it on a Buchner funnel and do the melting point. And the melting point is this, which is essentially the melting point of dibenzyl acetone, but a little wider, a little lower, not much. Now let's look at this video. Another commercial.
We can't wait to be doctors.
I already am a doctor.
Hello, everyone. Today we're going to be doing lab 6, which is the Aldo condensation. So the reaction that we're going to do,
I'm going to skip.
I'm turning more of a peach color now.
What they do is shake it. And you start seeing there's a solid just starting to form. We don't shake it like this. We swirl it in an Erlenmeyer. And if you look at this, you can see there's a solid in there. And then you cool it down in ice to help precipitate out any of the solid. You already, I skipped the part. All right, over here in the corner, this is called a Buchner funnel. And he puts filter paper in there. The bottom helps trap any liquid. This tubing here goes to a vacuum. And if you watch when he pours in the material in there, you wet it a little, the filter paper. Look at the bottom. If you look closely, you can see liquid come down. It's hard to tell in this video. But now he's going to pour the mixture of solid and liquid in there. And this will separate the two. And if you look at the bottom of the Erlenmeyer, you can see the droplets coming down, and the liquid is separated from the solid. And you can, to get more out of there, he's putting a solvent that's cold so it doesn't dissolve in there. And he'll do it again, and you collect it. No, I don't see it. But anyways, what you get from this is a yellow solid. There you go. You can see it in there, the yellow solid, and that's the dibenzyl acetone. And then you take a melting point to identify it. Now, the important part of this lab is to see what's happening stepwise. And I will post, I didn't, but I will. Later today, this is a step-by-step mechanism. Everybody see that on the crossed Aldo mechanism? on your screen, you have a handwritten to, all right, thank you, Janet. And what happens is on the ketone, acetone, you have 2 alpha carbons and base forms the enolate anion. And this reacts to give an aldehyde condensation, this molecule right here. Now, whenever you can lose water and whenever you can form double bonds that are conjugated, alternating single, double, and so on, it happens like that. And from this carbon, use a hydrogen, lose the hydroxyl group, H2O, water, and you form a double bond. Now the ring is double bonded and conjugated through this double bond to this oxygen carbon double bond. And that makes it more stable. Now, if you look at this molecule, this side still has an alpha hydrogen, a carbon with an alpha hydrogen. And base will form this enolate anion, and it reacts with the second molecule, benzaldehyde, to form this aldol condensation. And again, you lose water and you form this double bond. And again, you get more conjugation. Now, if you looked at the video, you'll see it's yellow. As you learn with carrots, double bonds absorb different types of light. And this one absorbs all the light, colors of the rainbow from white light, except the yellow color. And that's why it looks yellow. Now, listen carefully. The most important step of this reaction is the first one, base reacting with the acetone to form this enolate anion. The most important part of this mechanism, the first step, base sodium hydroxide acetone to form this enolate anion. And here's the melting point you would have determined, and you'd find out. Now, here are the questions. Number 2, just omit. Number 3, and number 4. And number 4, notice in black, it says, please explain this by drawing the key structure, the structure of a key reaction intermediate. Hint. And with that, I'm going to do something, because lab, we sometimes do it. I'm done. I'll see you tomorrow. Jimmy, the first thing in tomorrow when we start. If I don't do a review, but I will, because it'll be on my mirror, let me know and look real mad at me and say, you promised. And with that, I'm going to say, Gang gesund. I'm finished for today. Bye.